Okay, we are back again. So, in the previous lectures we have seen that delta p tie 1 to that scheduled tie power flow, that is sigma I is equal to 1 to 2, j is equal to 3 to 4, Cpf I j into delta p L j, right, and this is minus I is equal to 3 to 4 and sigma again j is equal to 1 to 2 Cpf I j delta p L j. So, this one we have actually discussed and told you how to do this. So, basically what happened, that suppose you have your that Cpf matrix, right, Cpf matrix. So, say I am just 2 discos and 2 gencos are there in each area. So, this way I am making it, right. So, there will be 14 into 14, 16 element. So, disco means, say this is disco 1, we make D1 in short, say D2, disco 2, disco 3 and disco 4, 4 distribution companies, and this is your genco 1 and this is your genco 2, this is your genco 3 and this is your genco 4, right. So, here you have this participation, a contact participation factor, this is Cpf 11, then Cpf 12, then Cpf 13, then Cpf 14, right. Then Cpf 21, Cpf 22, then Cpf 23, then Cpf 24, right. Then Cpf 31, then Cpf 32, then Cpf 33, then Cpf 34, right. Then this one is Cp overwriting on it, does not matter, Cpf 41, then Cpf 42, then Cpf 43, then Cpf 44, right. So, if you look into this equation, then first thing is that you have a distribution companies 1 and 2 are in area 1 and G1, G2 gencos are in area 1, and distribution companies D3 and D4 are in area 2 and power is being drawn from 1 to 2 by these distribution companies. So, D3 that it has and your what you call, and this side that 4 distribution companies power demand is, this will be very easy to understand, I mean easy way to understand delta PL2, delta PL3 and delta PL4, right. So, distribution companies your in area 2, that is D3, that is disco 3, has contact with generating unit in area 1, that is Cpf 13 multiplied by your delta PL3. So, the first term will come Cpf delta 1 your 13 delta PL3. Similarly, Cpf 14 with your that distribution company in area 2, that is distribution company 4 disco 4 has contact with your generating company in area 1, that is G1, that is Cpf 14 delta PL4. So, Cpf 13 delta PL3 plus Cpf 14 delta PL4. Similarly, distribution companies in area 2, that is D3, that is disco 3 has contact with genco 2 in area 1, that is why second term will come Cpf 23 delta PL3 plus your distribution companies in area 2, that disco 4 has contact with G2, that is your Cpf 24 into delta PL4. So, this term is coming because of this block, right. Similarly, and the distribution companies in area 1, right, it is drawing power if it has a contact that is in area 2, that is genco 3 and genco 4. So, this is distribution companies D1. If you look into that it has a, suppose it has a contact with Cp31. So, look into that, when I is equal to 3, Cp31, then delta PL3, right. Then Cp, then distribution companies 2 also has some contact with generating companies 3 in area 2. So, that is Cp32 your Cp31 into delta PL1, then Cp32 into delta PL2, right. So, this term is, these two are attached with this one. Similarly, if you take the distribution companies 1 and 2 has contact whatever they have with your genco 3 and genco 4, right, then this part will come. So, because of that your what you call that which power will what power will flow through the tie line, only this block is necessary and this block, and these are the this block and this block, basically their distribution companies have contact with their own generating companies, that means the same area, right. So, that is why first you consider this part, right, whatever it is this part minus that this part, right, and just you block it So, this part whatever it comes CPF 13 into delta PL 3 plus CPF 14 delta 1 delta PL 4, then CPF 23 delta PL 3 plus CPF 24 delta PL 4. This is this term minus here you take CPF 31 delta PL 1 plus CPF 32 delta PL 2. I mean everything you put in bracket, right, plus CPF your 41 delta PL 1 plus CPF 42 delta PL 2 minus inside that all this plus, right. So, this way you will easily get that what is that scheduled tie line power flow. This is a simple I told you number of distribution companies and your what you call generating companies it may be different. So, it does not necessarily mean that equal number of GENCOs and DISCOs will be there in each area, but this is the way. This is actually drawing power, I mean this block actually it is from 1 to 2 and minus because direction is your 1 to 2 minus it is 2 to 1, right. So, this way you can easily make it. So, I am clearing this one, right, and then your just hold on, then that the tie line power, that error, the delta p tie error, it can be defined as delta delta p tie 1 to actual, right, minus delta p tie 1 to schedule, right. So, this power is known, because we know how much power will flow, and this power actually actual one will come through your simulation. So, at steady state that delta p tie 1 2, right, error has to be 0. So, if it is 0, then at steady state that delta p tie 1 2 that actual, right, because this is equal to 0 because error is 0 will be equal to delta p tie 1 2 that your schedule power. This has to happen. And next one is that delta p tie error vanishes your your delta p tie 1 vanishes, right, in the steady state. So, I told you it will be 0 and actual tie line power flow reaches the schedule power flow. This error signal is used to generate the respective AC signal as in the traditional scenario. So, there we are also taking that AC 1 is equal to B 1 delta F 1, right, plus delta p tie 1 2, but here it is deregulated environment, that error is nothing but the actual minus schedule because you have the contract. So, that is why that schedule power flow will come, and AC 2 will be B 2 delta F 2 plus as usual A 1 2 delta p tie 1 2 error. So, this is equation 6, this is equation 7, this is that your area control error, right. So, now for two area system as shown in figure 3, right, contacted power supplied by ith GENCO is given as, that is your J is equal to 1 to n number of distribution companies are 4, because in area 1 2 distribution companies, area 2 2 distribution companies. So, n DISCO is equal to 4. So, contacted power will be actually sometimes we define that this one is equal to delta PCI, but here I have written delta PI, it is okay, but next when we will take the load following another version, there I have taken delta PCI, they are same. So, it is J is equal to 1 to your n DISCO for CPF Ij delta PLG. In general for better understanding, just I am overwriting, look at that, say this is just hold on, suppose this is delta PL1 for your better understanding, say delta delta P1, delta P2, delta P3, delta P4, right. So, this one what you will get, that you make your CPF matrix, that is your I am due to the space problem I am just making it here, say this is your delta PL1, delta PL2, delta PL3, just hold on, let me enlarge this one, just hold on. So, suppose it is your that delta pi like this. So, you can I am just overwriting, see how is it, say this is my just hold on, say this is delta P1, this is delta P2, this is delta P3 and this is delta P4. This is the contacted power demand, right. What will be the contacted power demand is equal to, you can make it that your this one, that your CPF 11, CPF 12, CPF 13 and CPF 14, right. Then CPF 21, CPF 22, then CPF 23 and CPF 24, right. Then CPF 31, then CPF 32, then CPF 33 and then CPF 34, right. Then CPF 41, then CPF 42, CPF 43 and CPF 44. This way you write into this one delta PL1, delta PL2, delta PL3 and delta PL4, right. So, this way if you put, this is the contacted power demand, right, that is what is your what you call by GENCO 1, GENCO 2, GENCO 3 and GENCO 4. So, in that case you can write that means delta P1, for example, 1 I am writing delta P1 is equal to CPF 11 delta PL1 plus CPF 12 delta PL2 plus CPF 13 delta PL3 plus CPF 14 delta PL4, right. So, this is the contacted power for your what you call for GENCO 1. I mean your similarly delta P2 also CPF 21 delta, this way you can find out. So, if you as delta PL1, PL2, PL3 and PL4, these are all the power demanded by the 4 different distribution companies in this case, and CPF is the contact participation factor which will be specified. So, you will be knowing contacted power demand delta P1, delta P2, delta P3, delta P. So, generally we write delta Pi is actually contacted power, sometimes we write delta PCI, C stands for contacted power, same thing, right. So, this is how we can get it, the direct or what you call that contacted power demand. So, same thing actually same thing, right, whatever we have written here, same thing here also. In same thing here we have written here that j is equal to 1 to n disc. If you put I is equal to 1, then it will be CPF 11 delta PL1, CPF 12 delta PL2, CPF 13 delta PL3 plus CPF 14 delta PL4. If you put I is equal to 2, so you will get delta P2. So, it is j is equal to for ith GENCO, and for this case I is equal to 1, 2, then 3, then 4, right. So, you will get delta P1, delta P2, delta P3 and delta P4, but that matrix form if you write, so no need to recall this one, easily you can get it, right. So, the block diagram of two area AGC system in a deregulated environment is shown in figure 4a. I am coming to that. So, simplified version of figure 4a is shown in figure 4b. For I is equal to 1, I showed you that delta P1 is this one, this I showed you. So, in the matrix form just now I showed you, right. Similarly, you can get delta P2, delta P3 and delta P4, right. And another thing is that in figure 4b I am coming to that delta PUC1 and delta PUC2 are uncontacted power demand if any. What is uncontacted power demand? I will come later. So, this is actually I have to I have to reduce that size, just hold up, it will be readable for you when you read it, but you will get the notes, right. Unless and until full block diagram I cannot do this, it is very bigger one. So, in this case if you look into that in area 1 2 generation companies are there, that is my this one is this one GENCO 1 and GENCO 2. Similarly, area 2 you have 2 generation companies, that is this one and this one, this that transfer function model is given, right. And already we have seen for conventional 2 area interconnected system, in area 1 2 distribution companies are there, that is power unit load of DISCO 1 and power unit load of DISCO 2, that is in area 1. And area 2 you have another distribution companies, power unit load of DISCO 3 and power unit load of DISCO 4, right. Now, how we will conceive this block diagram, because in deregulated system block diagram is certainly different. Now, we have seen just now we have seen that contacted power demand for this unit right, just we have seen that CPF 11 delta PL1 plus CPF 12 delta PL2 plus CPF13 delta PL3 plus CPF14 delta PL4, right. So, in this case for that delta PL1 is the power demanded by this distribution company 1 delta PL1. Similarly, for this one it is delta PL2, right. Similarly, for this one it is delta PL3 and this is your delta PL4, that is the total power demanded by these distribution companies. So, if you look into this, just see that this is delta PL1 multiply this one. So, CPF11 delta PL1, this is delta PL1 because this distribution company 1, then this is delta PL2. So, it is CPF12 delta PL2, right. So, all these things coming together, look. So, these two going to that this one, but two more terms will be there. Then what is there? That CPF13 delta PL3 and CPF14 delta PL4, they are also coming. If you look into this, they are also coming here, right. Here also coming this one. That means, and here also CPF11 delta PL1, CPF11 delta, this is also coming here is the summing junction. So, that is your delta P1, the contacted power demand, that CPF11 delta PL1 plus CPF12 delta PL2 plus CPF13 delta PL3, here it is CPF13 delta PL3 plus CPF14 delta, all are coming to this your what you call mathematically what the GENCO has the contract here. So, all are coming together, right. So, similarly, so this one I am clearing. So, similarly, if you look into this, that CPF21 delta PL1 plus CPF22 delta PL2, these two will be coming here, right, for this one. Then CPF23 delta PL3, this is your delta PL3 for DISCO 3, this is delta PL4, already I have told you, understandable too, right. And CPF24 delta PL4, if you look into that, they are also coming to that GENCO 2. So, that means that you have to give the feedback, the total contacted power here. So, for example, here the total contacted power feedback I told you, if you sum it up, it will be delta P1. Similarly, here it will be delta P2, right. So, similarly if you see here, if you see in the area 2, right, area 2 where you have, if you look into that, then for your delta P3. So, this is your unit 3, this is your unit 3 for area 2 and this is GENCO 3 and this is your GENCO 4. So, when it is coming to your GENCO 3, then your delta P3 will be CPF31, right, delta PL1 plus CPF32 delta PL2. So, if you look into this, the CPF31 delta PL1 and this is your this is actually DISCO 1 delta PL1 demand, DISCO 2 delta PL2 demand, DISCO 3 delta PL3 and DISCO 4 delta PL4. This we have seen, I have already just mentioned like this. So, here it will be CPF31 and this is your delta PL1 and this is your delta PL2. So, CPF31 delta PL1 and CPF32 delta PL2 add it, and if you look into that, right, it will be coming to this unit 3, right. And similarly, your what you call similarly if you take now CPF31 32, now CPF33 and CPF34. So, this is delta PL3 and this is delta PL4. So, CPF33 delta PL3 plus CPF34 delta PL4, if you come like this, you will see that it is coming to this unit 3. Just hold on, this is your coming to the unit 3, right. And here also other one also coming to your unit 3, that is your CPF31 delta PL1 plus your CPF32 delta PL2, right. It add and look into that, it is coming and it is your what you call, it is coming like this and your basically it is getting added here, right. It is very bigger block diagram. So, that is why a little bit your this thing, little bit your little not here, it is here. So, that is why little bit complicated. When you will get this note, at that time you enlarge it and just see this, right. Similarly, other one is delta P4, same as this, that CPF41 delta PL1 plus CPF42 delta PL2 plus CPF43 delta PL3 plus CPF44 delta PL4, right. So, all these things 41 delta PL1 and 42 delta PL2, it is taken from here, it is coming like this, it is coming like this, it has come here, and from here also 43 delta PL3 and 44 delta PL4, it has come here, right. So, this is actually your that whatever contracted power demand will come. So, that mathematically you have to model. So, basically what happen, all feedback you have to give at this point, right. So, input to the governor turbine, right. Now, next is your what you call that delta your PL local, right. So, what you have to see is that your delta PL local, I am writing here that delta PL 1 local means that you have two distribution companies in area 1, their total power each distribution companies demanding power delta PL 1 and delta PL 2 respectively. So, delta PL 1 local will be delta PL 1 plus delta PL 2, right. So, that is why delta PL 1 local means it is delta PL 1 plus delta PL 2, right. So, similarly, when you come to delta P 2 local, so area 2 you have that two your distribution companies, their power demand is delta P 3 and delta 4 because DISCO 3 and DISCO 4. Therefore, that delta PL 2 local is equal to delta PL 3 plus delta PL 4. So, this is actually delta PL 2 local actually nothing but delta PL 3 plus delta PL 4, that is the meaning. Next, if you come here, that this is actually this is delta, this part that is the tie power, this is actually delta P tie 1 to actual, this is actually delta P tie 1 to actual. So, that is written here also, and this is actually delta P tie 1 to schedule. So, actually what happened, look, the first term of that equation, that whatever we wrote that equation, that that delta P tie 1 to your schedule value. So, demand of DISCOs of area 1, A1 means area 1 from GENCOs of A2, that is area 2. So, that is why this plus sign is taken, and minus demand of DISCOs of A2 from GENCOs of area 1. So, that is your minus. So, this actually give delta P tie 1 to schedule power, right, and this is actually and this is delta P tie 1 to actually or what you call that your actual one. So, these are compared here, these are compared here. So, basically when it is compared means this is your put sigma. So, if this is my delta P tie 1 to actual, right, and this is my say minus delta P tie 1 to that is your schedule power, right. So, that is why it is made like this for just understanding, and then output of this one it is nothing but delta P tie 1 to error, that error signal, and then this error signal, and this is your frequency, area 1 frequency is deviation is delta f 1 and area 2 frequency is delta f 2. So, this delta f 1 is coming here through B 1. So, B 1 delta f 1 plus delta P tie 1 to error, and this output is nothing but the area control error of your what you call area 1, right. Similarly, if you look into this, that area control error AC 2 means this is your del f 2. So, it is coming B 2 del f 2 here plus A 1 2 into delta P tie 1 to error, right, and here it is AC 2, right. Then now I am clearing it, then this is integral control error in area 1 and this is integral control error in area 2. We have taken integral control only, but if you want but you can your what you call, you can choose other types of controller, but from practical point of view generally that utilities who are using this controller generally they prefer that your integral controller or proportional integral controller, but not derivative controller for thermal system, right. So, actually derivative controller for thermal system is not recommended, right. So, and their gain of this, because every unit has your that your generation rate constant, right, and this is a physical constant for the from the point of view of the thermal units. So, that is why the gain generally will be very small, right, maybe 0.1 or below that in reality when you are considering the generation rate constant, and in that case what will otherwise what will happen, that system will become unstable, right, very small integral gain, and proportional also may be very small, but integral gain is preferable. But if you want to experiment PID, I told you for hydro system it is derivative is okay, but for thermal system that derivative action is not recommended, derivative type. You find out that why it is, right. So, next is, so after this the output is u 1, that is the control law, it is u 1 is nothing but your minus k I 1 integral of AC 1 dt. Similarly, u 2 is equal to nothing but your minus k I 2 integral or what we call minus k I 2, that integral of AC 2 dt, right. And then this A 1 1 dash and A 1 2 dash and similarly A 2 1 dash and A 2 2 dash, we call this is AC participation factor. Sometimes we use that AC your what you call AC participation factor, sometimes we use that is APF, right. So, basically APF say 1 is equal to, I can make it that A dash 1 1, that is area per AC participation factor. Similarly, for unit 2 AC participation factor, that is nothing but your A dash 1 2, right. So, similarly here also, but I have made it just to make the symmetry that A dash 1 1, A dash 1 2, then A dash 2 1, these are actually AC participation factor. But as long as your schedule power everything is okay, then this whatever value you put, right, so, and there and mathematically A dash 1 1 plus A dash 1 2, it has to be is equal to 1, right. Similarly, in area 2 that A dash 2 1 plus A dash 2 2, it also has to be 1.0, right. So, it has to be 1. So, this actually this one and these two term, as long as it has effect on the your on the during transient behavior, right. But at steady state, as long as your as long as their effect may not be there, when that uncontacted power demand delta PUC 1 is equal to, if it is delta PUC 1 0 and delta PUC 2 0, this is actually uncontacted power demand, and this is also your here also this is actually uncontacted power demand. That means that distribution companies, they have some contact power with the different generation companies, but all of a sudden if any distribution company they want extra power which was not in the contract, that is also called uncontacted power demand, right. And that is why this is reflected here delta PUC 1 and this is reflected here delta PUC 2. If this is 0, if there is no uncontacted power demand, then this that AC participation factor has no effect on the steady state, right. Only it has effect during transient condition, otherwise at steady state it has no effect, right. So, the now what difference we saw from the conventional this one, that deregulated system you have a contacted power demand, right, and accordingly you have to what you call that you have to formulate. So, basic philosophy remains same, only thing is that your one that every GENCO your input to the governor turbine, one additional signal has come. Apart from that, here the tie line power error equation change, right, this is second thing, and third thing is that this delta that uncontacted power demand, and of course, that your local load, right, it will be reflected as here, right. Similarly, delta PL to local, right. Thank you very much, we will be back again.